We are dealing with multiple choice questions and I have given you a variety in this set of questions. I would like you to copy the question first, answer them, and you can stop the video as I move on to give you the answers or my suggestions, right? So the best thing is that you should really stop the video and find your answer. And once you have got the answer, then move on and see my solution. That will help you a lot, okay? I don't really want to repeat it again and again, and so, well, that's up to you, okay? Now question 10 is about rational function and asymptotes. So I have two questions here, and I've seen them in the test paper. So go through them very carefully. A. Which of the following statement is true for rational function? Graph of a function can cross horizontal asymptote. That's A. Graph of a function cannot cross horizontal asymptote. So one of them should be true, I think. C. Graph of a function can cross vertical asymptote, and none of them. So these are the choices. Make your selection. Question B. Consider f of x equals to x over x squared plus 1. Now, with respect to this function, let's answer the questions. A. Graph of the function crosses horizontal asymptote. Oh, that's similar to this. Graph of the function has no horizontal asymptote. C. Vertical asymptote is at x equals to minus 1. D. Horizontal asymptote is along y equals to 1. Okay, so you can answer these questions, and here are my suggestions. Let's go back to A. Which of the following statements is true for rational functions? It says graph of a function can cross horizontal asymptote. Many students think that that is not possible, right? But yes, horizontal asymptote is only defined at infinity, right? So when you have a graph like this, and let us say horizontal asymptote is this line, correct? That is your horizontal asymptote. You should remember that horizontal asymptote is actually defined in infinity, not in the domain, right? So as x approaches infinity, what happens to the function value? If it approaches a fixed value, then we have a horizontal asymptote, otherwise not. The only thing is that your function can go from above or from below, right? Either way. But there are possibilities where the function can cross your horizontal asymptote, right? It could be kind of like this. Do you see that? Thereby crossing and also meeting the criteria of going from either side of the asymptote. Do you see that? So option A is the correct answer, right? All others are wrong. Graph of function cannot cross the horizontal asymptote. I've seen many students marking this. And therefore, I've had question number B here. This is an example of this kind of a graph, okay? Let's see how. I'll not really sketch the graph for you, but I'll leave that for you to do, okay? But I'll give you a logic. Consider the function f of x equals to x over x squared plus 1. Now, you can see that x squared plus 1 will always be positive, right? Now, this is never going to be 0, correct? So there is no question of having any vertical asymptote in this case. So those options are wrong. Second, horizontal asymptote. Well, the denominator degree is higher, so we do have a horizontal asymptote. And in this case, the horizontal asymptote for us is y equals to 0, right? So y equals to 0 is the horizontal asymptote for us, correct? Now let's try to see how our function will approach y equals to 0. If I have x as a positive value, then since denominator is always positive, my function will have positive value. If x is negative, my function will have negative value. If I have positive large value, then I'll approach 0 from the positive side, correct? And if I have negative large value, denominator will be positive and numerator will be negative, so I'll approach this from the negative side. Another thing which you notice here is what happens at x equals to 0. If x is 0, then we get 0 over 1, which is 0. So we do have x-intercept and y-intercept both at the origin. See, This is our horizontal asymptote since the denominator is of higher degree, but we do have x and y intercept. That means the graph is crossing. Graph is crossing the horizontal asymptote. Do you see that? That's how it is. So many functions use find the graph of the function crossing horizontal asymptote. Is that okay? So I'll leave it here, and as an exercise, try to sketch this and see for yourself how the graph of this function looks like. So the option here is graph of the function crosses horizontal asymptote, and that's the real answer, okay? I hope you learned from this. Try to share it with your friends so that they don't make this mistake. Thank you.